Hi, everybody. Welcome to our webcast today. We're very happy to have both Matthew Groves, DevRel engineer, and also Laurent Dugan, who runs our DevRel team. He's the director of developer relations, both at Couchbase. Both huge amount of knowledge, developer knowledge, huge in the developer community, always out speaking on various topics. This one is a popular one. Matthew was just saying when he hits the road, this is one of his most popular sessions, data modeling, and that proves to be true with you all here today. So before I turn over to Matthew and Laurent, I do just want to mention this is part one of a two-part series. We're going to continue this series the last week of February. If you look at the docs section, there's a link to join that session as well. So I hope this one really piques your interest and you're interested to learn more. And please do join us for part two in February. And now I will kick it over to Matthew to get started.
Thank you very much, Suzanne, and thank you all for being here. We are going to talk about some JSON modeling today. I'll be going through the slides, and Laurent will be here as well, kind of keeping me on my toes and making sure everything is good. So thank you all for joining me. It's great to see such a wide variety of locations in the chat there. So thank you all for being here. So we're talking about modeling today. And in the relational world, most developers, most of you in the chat are probably familiar with the relational way of modeling data. This is what comes to mind for me, a very similar picture like this. But for the benefits of a non-relational database, you have to think differently about modeling. That's what we're going to talk about today. So this is my agenda, our agenda for today. We're going to spend some time talking about, why NoSQL, what are the benefits of it? Why would I want to switch to that? Or start using it on my project. We'll talk about how JSON is modeled differently than relational. We'll do a compare and contrast. And then accessing data is a very important thing to keep in account when you're talking about data models. So we'll talk about accessing data as well. I have some examples to work through that kind of get to the root of the main issue people usually ask about, which is embed and refer. We'll have some time to talk about LLMs and Capella IQ and their effect on data modeling and how they can help you with data modeling. We have time for questions at the end. But yes, please, if you have questions, put them in the Q&A tab there, and that way we can keep track of those questions, and we'll get to them as soon as we can. So why NoSQL? What's the big deal? Well, in my mind, there's kind of four high-level reasons why organizations, teams, developers look into NoSQL, the benefits of them. So the four are scalability is the big one. So horizontal scalability specifically. Availability is important as well. This is a picture I took of my wife at a movie a long time ago, actually, but I said I'd use this in all my slide decks because she's demonstrating availability quite well just by getting some soda. Speed is an important one. People are always interested in better performance. And this can be an architectural issue, access patterns we'll talk about today. It could involve how much caching you're using, other optimizations. Flexibility, and this is the big one we'll talk about mainly today, is the effect that you can have on your data with a flexible JSON data model. It's less constrained than relational. So all these issues are ones that we're going to focus on. We're going to mainly look at flexibility today.
So who's that guy? Because I know the Flash, but I'm not sure who that.
Oh, okay. That might be an American thing. That's Gumby. He's a little creature. He's made out of clay, and he's very flexible. He can stretch and move around all that stuff.
Nice.
So that's why I use him.
Thanks.
All right. So here's an example of relational data modeling, of which we're all familiar. This is an example of two tables, and a user might have multiple addresses. So to get the address info for a user, you need a join. So this is your typical normalized data stored in a table. Now with JSON, one approach you can take is called denormalization. So we can combine the data from those two tables, even if there's multiple addresses, into one document. So why would we do that? And let's go back to those four whys. For one, scaling. If data can be more independent, then it can be stored more easily on multiple nodes. So we can put that data anywhere we want to in our whole cluster. Availability, so when there's multiple nodes, we can have backup replicas for quick recovery. And speed is one reason. So in this case, we're replacing a SQL join or multiple lookups with a faster single get operation, which can be even faster if the database has a built-in cache, like Couchbase does. So what about flexibility, though? That's what we're focusing on today. So let's look at the broader picture of a relational schema. So suppose for this schema, I want to add a column like country to one or more of these tables. Adding a new column can often affect availability and can require downtime. If you do an alter statement, sometimes you have to put your database into read-only mode or some sort of maintenance mode, at the very least. But what if the country doesn't make sense for every row, right? A relational table assumes that every piece of data has every one of those values. So if it doesn't make sense to have country in one of those rows, well, then we have like a nullable field possibly, and we have some null data in there, and it gets or some sort of special flag data. So it gets more complicated just because we have to make all that data, all those round pegs fit into a square hole. Making that same change with a document database, it does not require an alter statement. As a developer, you can just start adding new bits of data to documents as you need to. It does not require every document in the given collection to have a country. This is just a minor example, of course, but if you extrapolate this to a real schema with hundreds of tables and the often changing business requirements that we as developers have, the flexibility benefits can really start to add up. So some of the use cases, to be more specific examples of NoSQL, it's very versatile these days. It used to be NoSQL use cases were kind of niche. It was session storage, caching, user profile, but a lot of these use cases have been expanding. And I've been presenting this, as Suzanne said, for 6+ years, and this list of use cases just keeps growing. For instance, when I first started at Couchbase, finance and banking and healthcare, those were, not common use cases for NoSQL, but they're mature enterprise databases now. And so those use cases are absolutely in Couchbase's wheelhouse. And the last thing, of course, is a nice little quote, is that, if you're trying to do something better, different isn't always better, but better is always different. So just keep that in mind. Keep an open mind as you look through this modeling exercise and as you explore NoSQL databases. Okay, so let's get into some data modeling. Before I do that, any questions from the chat we should talk about there, Laurent?
There's maybe a quick remark about your sound. That's volume that's moving up and down.
Yeah,
looks
I
like
noticed that.
noise cancelling, or it's weird.
Yeah,
it's
I'm
all
not
right.
sure why it's doing that. Let me see if I can make any changes here.
So while Matthew's looking at his setup, does anyone has any questions or? What I'd like to know, I'm not sure, Suzanne, if we can do a survey, but I'd like to know if we are mostly with people using relational databases or if you are already all using NoSQL. If you, how do we do it? If you're using relational, please write a +1 in the chat. That works 100% relational. Thanks, Eddie. Both.
Yeah, that's a great question. I'd like to be interested to know what specific databases you're working with as well. So
it's one of the questions I ask often is how many data store are you using? Because I see people using one database, one cache, one search engine, and I already see that some people are using both SQL and NoSQL.
Yeah,
a lot of you are using both. Actually, that's interesting.
That's great. Okay, so let's talk about some modeling. And hopefully microphone issues will get better. It doesn't look like they are, but I'll do my best here. So NoSQL databases, they don't have tables. And mainly I'm talking about document databases today. There's lots of different types of NoSQL databases, but we'll be focusing mainly on JSON document databases. So what do they have instead of tables? Now, this can vary from database to database, but oftentimes you're going to see at least a collection. So Couchbase has that, Mongo has that, Cosmos has that. And collections are kind of like a table, and they may belong to something like a scope, which is the next level up. So a Couchbase has that, for instance, and kind of like a relational schema you might see in some situations. And then scopes may belong to another level up. In Couchbase, we call this a bucket. They may be called databases or something like that in other tools. But this is kind of the first basic step of modeling. Now, the decisions, the way you use collections and scopes isn't always related to modeling. It can be multi-tenancy related or replication related, index related, access control, and so on. But it's certainly a part of it that you'll have to think about going forward. And so I have a little translation guide here that kind of maps relational concepts. A lot of people in the chat using relational. So that table or that column on the left is the terms you're probably familiar with. And if we're going to map those to concepts in Couchbase, it's not just a name change, it's different things, but it's kind of the same level to kind of help you understand the different components and what you're working with there. Okay, so with data modeling, I kind of alluded to this before, but with your relational data model, you have normalization that's basically required. You have to use foreign keys, you have to use constraints, you have to use multiple tables, all those things. It's just what you have to do. It's very prescriptive in that case. Now, in a document data model, you can take that same approach if you want to. You can have very normalized data if you want to. But you can also relax that normalization, and you can get a little more flexibility there. Now, of course, there's trade-offs to this. I'm not saying one is inherently better than the other, right? But with the relaxed normalization, you can more easily achieve those four things: availability, performance, scalability, and flexibility. And so normalization is possible, but it is relaxed. So let's look at some examples right here. So on the left side, we've got a relational example. On the right side, I'm going to have JSON examples. And this is a very simple customer table, and there's 3 columns of data, and we can pretty easily translate this into JSON if we want to, just a very flat piece of JSON. And we can get more flexible if we want to. We can have first name and last name be sub-properties of a name object. And maybe we could add suffix and middle initial and prefix and all sorts of things if we need that level of granularity or flexibility. Now, if you're not comfortable making decisions about data, JSON modeling is going to be challenging for you because it's not as prescriptive as relational. But one thing is that unlike a relational database, the decisions you make here are a little more easily reversed because, again, you have data flexibility. Let's look at a more complex example. So we've got a second table now. And usually if we have multiple payment methods, that has to be in relational. That's a second table with multiple rows and a foreign key. So a single customer profile consists of 3 rows across 2 tables, and you got to have joins to put those together. In a JSON model, one way we could model it, we could do it the same way, but we could also embed that billing data into an array, so it remains as a single document. So if you have a use case where your data access consists of querying a customer join with billing information, and maybe there's an ORM involved, like Hibernate or Entity Framework or Active Record, and that happens a lot. Well, this is right away one change you can make that's going to lead to a lot better performance just by changing the access pattern and the way you're modeling the data. And let's look at one more complex example here. So we've got orders, order details, and products. Now in the JSON database, we can have a customers collection, a products collection, an orders collection. And again, back to decision time. Do you want to embed those order details into the orders document, or do you want to keep them separately? So it could be better performance to store them in the orders documents if you want to, and more flexibility. So for instance, does every order detail have to have a quantity? Sometimes it doesn't make sense to have a quantity of something. If it's a digital good, for instance, subscription, quantity doesn't really make much sense. So there's some options there for flexibility and performance improvements. Really, it comes down to this. This is kind of the core decision. There's other decisions to make, but this is the core decision when it comes to JSON modeling, is how do we model our relationships? So you can either embed or you can refer. In a relational world, it's always refer. Foreign key, separate tables. In JSON, you can choose. You have different options. So there's some tips about when to embed, when to refer. It's not always one or the other. These are not hard and fast rules. It's just kind of tips or rules of thumb. So for example, if A owns B, and A and B are often accessed together, and it's mostly reads, and the combined data is relatively small, then it makes sense to embed. So my recommendation is, if you're in doubt, try to embed or consolidate first. and then split them up if it makes sense to. Okay, and then one more thing about modeling before we get on to access patterns is there are some tools out there that can help you. It doesn't have to be just all completely on your own, completely in your own mind. These are tools you can use to collaborate with other developers. So some of these you might already have access to at your organization. So Irwin, for instance, has NoSQL modeling tools that support Couchbase. Accolade, a NoSQL modeling tool, supports a lot of databases, including Couchbase. And I'd recommend if you just want to start simple, no frills, something like JSON editor online.org is a pretty good tool to help you with modeling and diffing and so on. And actually, one of the newer things for this version of the slide deck that I'm giving today is there's actually some Couchbase IDE plugins now. This one on the screen here is for IntelliJ, and that comes with a relationship mapping tool that can show you visually how your documents can map together, and a lot of other features as well. It's not just that, but that's one of the features of that Couchbase plugin. So there's a link to that at the end of the slides if you want to check that out. So that's basics of data modeling. I've got some more examples coming up about embed and refer, but next thing we're going to talk about is accessing data. So I just wanted to pause again and see if there's any comments or questions from Laurent that we can discuss before we move on.
So we have an interesting question that unfortunately won't be treated during this presentation, but we are being asked, how do you manage document versions with a temporal capability? So I'm assuming temporal meaning time series. Joel, if you can precise that, that'd be great. If you're talking about time series data. Yes.
Yeah, so I know Couchbase has some time series capabilities, and as far as if different versions of data, there is some change data capture features in Couchbase. I think you have to use the Magma engine for some of those, but yeah, there's some capabilities for doing that. And Couchbase also has an eventing service that allows you to write custom code to respond to changes. So there's some things you can do manually there if you need to. So there are some capabilities for that. Yes. But yeah, I won't be talking about that much today. Sorry.
Is the EID plugin available for Visual Studio? Visual Studio Code, I just answered yes, but that's my, I don't use Visual Studio, so I always think about Visual Studio Code. It's available for Visual Studio Code, not sure for Visual Studio. Yeah,
there's nothing for Visual Studio yet. That's that's a much more difficult plugin to build, and compared to Visual Studio Code, a much smaller audience. So that's not been a priority, but it could happen eventually. And I don't know if the Visual Studio Code plugin has relationship diagrams just yet, but I'm guessing that's on the roadmap and that will be coming. But they are in the IntelliJ ones for sure. Okay. All right. Going on to accessing data. So one of the things that's key to understand the difference in modeling relational and modeling JSON is that when you're using relational data, you basically only have one option only, and that's SQL. With a JSON database, you have multiple options to access the data, and sometimes one of those options is SQL. But every JSON database is going to have some basic CRUD operations that are based on document key. So this is an example of a document with a key of user 1 and the different CRUD operations you can do. I think these are JavaScript examples, but of course those would be available for Java, .NET, Ruby, PHP, and so on. So you can access a document directly by just providing the key. So you don't have to go through the SQL engine for that. And one other thing that's important when thinking about modeling, and you'll see maybe why later, is a subdocument API. And so document size, if you're collapsing data into one bigger document, you might be concerned about really large document size, sending that back and forth across the wire. So one of the ways you can improve that is if you just need to work with a portion of the document, a subdocument, if you will, there's an API for that says, I just want to change this one bit. So I only have to send that information across the wire. I don't have to get the entire document. So I can operate on parts of the document. So that's going to improve performance, improve latency. So I mentioned earlier that relational is SQL only. You may have heard that NoSQL stands for not only SQL, and I believe for a database like Couchbase, that is actually true. So Couchbase has a full ANSI compliant SQL implementation called SQL++. Now, I should mention that there are some other databases out there that offer SQL or SQL implementations. So Cosmos and DynamoDB have them, but they are very limited. They don't offer joins, for instance. Couchbase is fully compliant with all those things. Now, other document databases offer capability like SQL, but they have their own proprietary language, for instance. Like Mongo has their MQL language, which is something you have to learn from scratch. Dynamo has their own API, which again, you'd have to learn from scratch. Whereas a lot of you already know relational, you can take those relational skills of writing SQL and apply them right to Couchbase and be productive almost right away. This is one of my favorite reasons I like Couchbase. So just a quick comparison here. I'm not going to go through all these bullet points, but this is just 2 of the APIs you can use with Couchbase. There are a handful of other ones I'm not going to cover today, unless there's a specific question on them. But you can see kind of the trade-offs here. So key value is good for simple operations, very, very fast. The query API is good for more flexible operations. There is some overhead involved there because we're using an engine for that. And this is just the architectural comparison of those. You can see the key value lookup just engages data service only, very quick, whereas the query service has to go through the standard steps of parsing the query, looking up indexes, cost optimization, all those sorts of things that it has to go through. But sometimes you can't just use a key value query for everything. You have to use a secondary query. This is kind of a performance comparison. Key values microseconds, query is going to be milliseconds. That's kind of the comparison there. But there are some times where an operation you're used to doing in SQL makes more sense in a key value lookup if that's available. So, for instance, if I'm querying a document by its key, a specific airport, if I'm used to relational, I might just do select where ID equals. But that's going to involve the query engine and parsing and indexing and all those sorts of things. Whereas if I have the ID, I can just do a quick lookup from the language of my choice. I think this is Java in this example here. And if I want a subset of fields, again, I could do select airport name and city, or I can do a admittedly more complex and harder to write piece of code, but much faster KV lookup using a subdocument API. So those are some ways to think about data access and how they affect your modeling. And we're mostly talking about key value and SQL++. There are other ways to access, again, the same pool of data. You don't have to copy data into other tools or keep them in sync. This was what Laurent was alluding to about, sometimes organizations will have a SQL database and a JSON database and a caching database and a search database. All have to keep in sync and they have to keep updating each other with different pipelines. With Couchbase and other multi-purpose databases, you have different APIs to access the same pool of data. Okay, so I'm going to pause again and ask for any questions or comments from Laurent.
Don't think we have any questions right now. Let us know if you want us to go faster, to slow down, to just please let us know. But so far, so good.
Okay.
I think people are excited to go into examples. Yeah.
Yeah. Okay. Well, this is a cool part, I think, for me as well, because it kind of demonstrates all these things together. So just a reminder that I believe the core of the hardest part of JSON data modeling is the decision about do I embed or do I refer. So this is just every modeling conversation I talk to pretty much boils down to this. There's other things to think about, like versioning, someone mentioned, but this is kind of the main thing. So I'm going to walk you through a use case to show you the trade-offs. And so what I've got here, some examples of JSON data for a music streaming service, kind of like a Spotify or Pandora or whatever. So I've got a model here, and I've got 3 documents, and these are in 3 different collections. So we've got a playlist collection, like a user profile collection, and a collection of actual tracks, right? So this is one playlist with 3 tracks in it, owned by a user. So this is very much a refer example. So this is very similar to a relational approach where all the data is split up in different pieces. And so the playlist document refers to the user document via that document key, 18695, and that's Morgan Freeman's playlist. And then the tracks all have their own keys as well, and each refer to a different track. So in this case, D, Q, W, etc. refers to this Rick Astley song. And so this is kind of the standard, very similar to relational model, although an array of tracks is, something you probably couldn't do very easily in a relational database, but very, very relational, very refer-heavy approach. Now, what are the pros and cons of this? So some potential benefits. In terms of performance, one of the benefits is that owner names tracks are separate lookups, which means that the playlist document size is relatively small compared to the much bigger embedded version we'll see later. And as far as queryability goes, we've got some consistency ensured here. So we're not embedding multiple copies of the user or multiple copies of the track. It's just a single track document that we're referring to. So it's always going to be consistent. Potential issues of this, though, is back to consistency. Updates to the track will update every single playlist. There is no snapshot, right? So if Rick Astley changes his name for some reason, I don't know, then that's going to be changed in every single playlist. And that might be desired behavior, but if, let's say, we're modeling a shopping cart, you might want to keep a snapshot of an item that's purchased in case changes to it happen later, changes in price or name or features or whatever. And multiple lookups. So this is kind of the main thing of this type of model is that if I want to look up a owner and tracks from a playlist, I have to do multiple lookups, multiple CRUD operations, or SQL join. So that can potentially be a performance issue. Let's look at different models.
I have some somewhat related questions about,
Sure.
You talked about joins. Most of the time when you want to do join, you do index, and we have an index question. We have, for SQL query to work, do we need to index the column or we can use any field, any column in the workflows?
Yeah, so in terms of development, if you're just working on the queries yourself, you can create an index that will allow you to query on any of those fields. That is going to be the equivalent of a full table scan. So not going to be very performant for production, but great for, trying to building your queries in the first place. Now, so then if you're going to be querying on any of the other fields, if I'm going to use a name in a where clause, for instance, that will need to be an indexed field to be the most efficient. And there are lots of different types of indexes that I don't have time to cover today. There's adaptive indexes, for instance, that I could group a bunch of these fields together so that I don't have to create, 10 different indexes. I could just create one index with 10 adaptive fields, for instance. And actually, that's one of the things that we'll talk about when it comes to Capella IQ and LLMs in terms of creating indexes. So now, one of the things I remember from the relational world is that as a developer, I was very lazy with indexes. And with a relational database like SQL Server, you can always do a full table scan. And that is not recommended for production, but we usually do it anyway because we get away with it, right? But that's not something you can get away with a large-scale database like Couchbase. Those types of indexes are going to be very, very problematic in production. So it's always good to have the correct indexes for production.
You would not believe the amount of issues I had in my previous job when I was operating a cloud provider and we were hosting lots of WordPresses backed by a database. And people use a variety of plugins that don't always come with indexes. And sometimes we had some incident because of that. So it is super important. We have another semi-related questions. Does the concept of a foreign key or constraint in general occur in the Couchbase database? And if so, are they implemented? And on a somewhat similar note between documents and constraint, if you delete one of the documents that referred in as a document, is it going to cause an issue in the database? I'm assuming, can you do an on-delete cascade, that kind of stuff?
Yeah. So the first question: are there foreign key constraints? And generally speaking, there are very few constraints in Couchbase or other JSON databases because they are designed to be distributed, and implementing constraints would be problematic and really a drag on performance. So those generally aren't there. So what I'm showing you here, I don't want to use the term foreign key because it's not a foreign key. It's just a key referring to another document. And then the other question is, what about if I delete a document? And then, so one option there is, I mentioned eventing earlier, and one of the events is on delete. So potentially you could put some code in there where if a document is deleted, you can then have some custom logic to handle that. And then, one of the things I often have learned in my career is that I very rarely want a true hard delete, right? I might want to mark a document as deleted, but still keep it in my database just for, future reference, or, in case I needed to look back at that document historically. So that might be another option, is to do more of a soft delete.
All right, let's go.
Okay. All right. So the next version here, this is a little bit more of a denormalized version. So notice that in the playlist document here, I've now got Morgan Freeman's name copied to this playlist from the user. All right. So think of it like a cached copy. So if I need to get the user's name, I don't have to do a second lookup. It's right there in the playlist. So that's going to save a join operation or a second lookup because it's already right there in my document. Otherwise, it's the same exact model as before with the tracks, and I still have a key, or sorry, an ID that points to another document key. So that's still there, but I am copying this name over. So what are the drawbacks of this? So potentially faster lookup time because it's fewer joins, fewer secondary lookups, and it's right there in my JSON document. And it becomes a single lookup now, so it's easier for me to query as well. Potential drawbacks, though, some of you might have guessed these already, is that it's an increased document size. Now, it's just one string here, so it's not that bad, but if I keep doing this more and more, it's going to make my playlist document bigger and bigger. And consistency could be an issue here, because if Morgan Freeman changes his name, well, now my data is out of sync, or I have to go and update all the other places where his name has been copied. So that is potentially an issue. If the name doesn't change very often, this is not that bad, right? And then, of course, multiple lookups may still be required. If I need more than just his name, if I need his address, for instance, it's still a second lookup involved here. So you can kind of see where this is going, is a trade-off between consistency and performance in some cases. But that's really up to you to weigh the pros and cons of that for your use case. Okay, and yeah, so potential issues. I mentioned the consistency. Yes, sorry, I didn't put that slide up yet. The last version is kind of the all-in-one. So I've embedded everything into this playlist document. The playlist data, the user profile, everything. All right, so this is just a single document that represents a playlist that includes all that satellite data. Potential benefits are single lookup, very, very fast, one get operation. And less can go wrong in that situation because I'm just looking at one piece of data. It's either there or it's not. Potential issues, document size is getting much, much bigger, of course. So if I have a user with a lot of tracks, I may need to work around that in some way, or may need to limit those tracks for the playlist. Consistency is a major problem here because now there's multiple copies of this same data. Every playlist that has this Rick Astley song is going to have a copy of all this URL, artist, title, everything. And so that could be a potential issue, especially if that data changes. And queryability, not a major issue here. No major issue with queryability, except maybe if you're doing some sort of text search, that might become an issue. You have to work around or keep that in mind. So I'm sorry about the audio issues. They seemed fine before we started, but hopefully we're getting through it okay. Just a quick pause here before we go to the next section.
Yes, so we have a couple questions left unanswered. Is there any best practice to restructure the number of indexes, like primary index is not recommended in production, that kind of things? Yes, there is. You should not have primary index in production. Other than that, there's probably others as well.
Yeah, I think that's basically primary index should not be in production, except for some very, very narrow use cases, and you still be very careful with it. As far as number of indexes, I don't think there's any limit that Couchbase would have. In fact, you can scale out your index services to have as many nodes to have an index service as you need. You can have index replicas. In some very large scenarios, those make sense. So I don't think there's any restrictions on the number of those. I think I've seen customers with as many as in the hundreds of indexes and running those without problems. You may have seen more than that, Laurent. I don't know.
Yeah, I think it's worth mentioning that you can do a variety of indexes. You can do covering indexes. You can shard your index, so index can have different sizes, can spread on different nodes. Because something we didn't mention in the Couchbase architecture, you can have as we split features into services. There's the index service, the query service, the data service that holds your data, and you can have as many of those as you want. So you can have as many index services as you want, and this way you can spread out your index. And like, there's a variety of things you can do. You can collocate your index. It's a job for a DBA. You still need a DBA when you do NoSQL.
Yes, I think sometimes we talk about NoSQL and its effect on DBAs, and I think especially for a large deployment, a DBA is still very valuable. It's just that they will be spending less time on kind of the really minor things that often take up a lot of DBA's time in organization, like adding a column, for instance. It's not a very taxing job for a DBA, but some organizations kind of force that process. Whereas a JSON approach kind of frees up the DBA to work on those much more important things like indexing and scaling and backups and things like that. So.
Right. One more. Sorry, Matthew.
Sure, no
what
problem.
strategy would you use to transition some of your more static data into a database that uses more JSON? Would you move some of that data into another database, Couchbase, for example, and do joins across two databases? Would you keep data in the first database and then somehow implement pieces of Couchbase into the existing relational database, like SQL Server, for instance?
Yeah. I mean, that's really, I can't answer that in general, right? That's a hard one to answer in general. I think my approach, even if you're moving from one relational to another, would be to come up with some way to slice up your application so that you can isolate the data as much as possible. So you don't have a lot of overlap or copy you have to worry about. But there are some tools that can sync databases, while you're transitioning. We've got some use cases from GlueSync that can sync between, SQL Server, Oracle, or whatever over to Couchbase, and they can sync in real time. So that's one way you can kind of start the transition. But then, I would just say maybe start dividing it up by use case and see if you can get some isolation that way. That'd be a good way, I think, to start. And proof of concept is always a good way to start as well. Just start really, really small with clear set of small goals and measurements to determine, is this going to work or not, and do that small proof of concept first before you take on a whole big, we're going to change the whole application. I wouldn't do that. That wouldn't be my first step.
Yeah. All right.
I think my voice is starting to give out too. So microphone issues and voice issues. Isn't that lovely? Okay. So let's talk about LLMs and Capella IQ. This is what everybody is interested in these days, is things like ChatGPT and so on. So let's start with ChatGPT and ask it the $64,000 question. Basically, should I embed or refer? And I'm giving it some more details about my use case, and I'm asking for code samples and pros and cons. And you can do this sort of thing if you have more information about your use case, about what languages you're using, what frameworks you're using, and so on. So this is just ChatGPT, a very general purpose LLM. And so it's giving me the pros and cons, which are, very similar to what I've been talking about this whole presentation, and also gives me some code samples. So I can look at those code samples. These are a C# and SQL++ to see, well, is this going to make sense in my code base to take this approach of, in this case, embedding those items, and what are the implications of that, and how often will I have to do a query like that? So size limitations. I like to look at the cons at these sort of things and see if it applies in my situation. So in this case, the cons are for a shopping cart, potentially large document. That's a good problem to have for shopping carts, I think. Your customers are buying too much, right? Conflicts are not a big deal on shopping cart because they're generally single user, right? So that's not a major issue to have to handle that. Updating individual items, this can be a bit more complex for sure, but we did mention the sub-document API earlier. It's going to help you if you need to update just one shopping cart item quantity, for instance. That's a pretty common use case. So looking at the code samples, does this approach make sense for my use case? The key value is very simple code there, and I can use SQL++ to do something more advanced, like query individual items. Uncommon access pattern, but might be needed. So let's look at the other way to reference those items. And for a shopping cart use case, let's start with the cons again. Complex retrieval, multiple fetches, probably joins. Now if I want that complexity, I can get that from a relational database already. There's no benefit to modeling it that way. Transactions add complexity. So Couchbase does support ACID transactions, but adding that much overhead for a use case as common as shopping carts, that could be a problem. And referential integrity. So someone mentioned this already as a question, foreign key constraints. So that's handled manually in Couchbase. So if I take this reference approach, it's more work for me as a developer. And looking at the code samples, that cart class does not look like one that I want to interact with as a developer. It looks already like it's going to be a pain. And then there's a loop I have to use to get all the items. So I'm introducing a lot more network overhead by making all those requests. So for a shopping cart, I'd probably stick with embed based on what this LLM is recommending to me. But hopefully here the point is not to go over shopping cart specifically, but to show you that LLM can help you make modeling decisions and even give you some sample code, and it can help you understand the trade-offs of that approach. So with that in mind, I want to talk about something called Capella IQ, which is basically like a generative AI chat that's built into Couchbase. And so lots of features that you can do with Capella IQ. It's natural language to help you with common developer tasks. So one very common task would be learning how to use Capella in the first place, right? How do I write a query? How do I do a lookup? That sort of thing. How do I create scopes and collections? I want to generate some data that I can work with for testing. And I mentioned creating indexes. It can recommend indexes for me. And also create some code samples. So this is just a screenshot of some of that happening in Capella IQ. You can work with data. You can ask it for a set of data to create that, and then you can have it refine that data, again, based on your natural language input. And then once you're happy with that, there's a button you can actually execute that, insert the data into the database. Working with queries is a very important part of IQ. You can ask it in plain English, create a query for me. And it has access to not your actual data itself, but the structure of the data. So it can give you some more intelligence of what that query might look like compared to something more general purpose like ChatGPT. And of course, you can refine that query and optimize that query for performance. And lastly, of course, you can generate, I mentioned this already, but you can generate code in your favorite language. So, okay, I've got a query, I've got some data. Now I want to actually code my C# application to interact with that. So IQ can do that for you. Oh, excuse me. So Capella IQ is something that's kind of in a private preview right now for Capella users, but that will be coming public and GA very soon. So that's all the slides I have. Definitely open to more questions or comments. Anything that you want to discuss, Laurent?
Yeah, that was an interesting question. I sort of answered on the chat. Is the design focused based on CRUD rules or query pattern? What is the recommendation?
I
think it's another kind of, it depends. Is the design focused based on CRUD rules or query patterns? Okay. My personal take is, well, it depends. And for the SQL and multi-model databases, you usually take the query patterns that are available to do your data model. instead of just normalizing everything like you would in relational. Relational gives you that I don't have to think too much about this. I'm just going to do a full normalization and it's going to be fine. With the SQL, you have so much choices that you sort of think about queryability first, and that's how you would then model. That would be my personal take.
Yeah. No, I agree. I think my kind of philosophy about it is when I'm working with Couchbase and I'm coding something, I want to use those simple CRUD operations as much as possible because they're simpler and because they're faster, a little lower latency. But I'm not going to try to work around that if there's a perfectly good SQL query that can do that. So it's a mix of both, but I tend to go CRUD first and embed first, and then work from there as I need more flexibility.
I think my favorite example is a user object. When you're storing a user, the key is probably a UID, a randomly generated ID. But as a user, if you want to log in, you're not going to remember the UID, so you're going to use your email. And so logical things to do is to do a select star from users where email equals blah, blah, blah. And so you're going to hit a REST API. It's going to pass the query plan. It's going to do all the stuff that you want to do with SQL. Whereas you could do what we call manual secondary index and create a couple objects. You could create an object which key is the email that the user remembers, and value is the UUID of the actual object. This way, you're only doing 2 key value gets, so 2 sub-millisecond operation instead of doing a millisecond operation with a SQL query. So that's a simple example that sort of shows you how you could.
Yep. Yeah. Well, I mean, I think the important thing is to keep your performance goals in mind, right? Because that do from a coding point of view, but it's potentially a much better performance, especially at large scale. So you have lots of options, and if your goal is performance, then you might have to do a little more coding work to deal with that. If your goal is, developer experience and ease of coding, you might just be trading off some performance for that, which is totally acceptable, totally fine.
Yeah, we have customers doing widely different things. Some people only use key value for the operational side of things, and they stick to SQL for analytics. Some do SQL all the time. It depends.
Yeah. The important thing is you have the options. You can do whichever one you want to, all in the same pool of data.
In the same app, actually. I think in the same
exactly
as well is a good example, because sometimes you want to be consistent, sometimes you don't, sometimes you want to be fast, sometimes it doesn't matter. So all about choices.
Yep.
How different is Couchbase compared to Ditto? I'm not super familiar with Ditto. I know it's a sync solution for mobile, I think.
I think I've heard of Ditto, so I'm not too familiar with it. So one thing we didn't talk about is Couchbase Mobile and Couchbase Sync Gateway today, which I don't have much time to talk about it, but it's basically a way of having a database on a device like a phone or some sort of embedded device that you can read and write to even without connectivity. So if you're in an area without signal, or you're in the back of a shoe store that doesn't have the Wi-Fi won't reach, then you can still read and write to your database. And then once your device moves back into an area with reception, the data will automatically sync. So that's a great use case of Couchbase Mobile. Not really related to modeling, so that's why we didn't really cover it today. But there's some great stuff with Couchbase Mobile.
I think we are on-prem as well, and we do peer-to-peer sync. I'm not sure that Ditto does that. Oh, it does peer-to-peer as well. Sorry, my bad.
Yeah.
Nice. Node.js IQ support.
That's one of the languages I believe that IQ can generate code for is Node, or JavaScript, I guess. But there's like 10 or 11 SDKs that the Couchbase supports, and I think IQ can generate, if not all of them right now, eventually it will get all of those SDKs in there.
Yes. Why is JSON used? Are there many or few non-JSON data stores?
That's a really, I've never had that question before. I'm interested to hear your opinion on it, Laurent.
So funny story. When I was at school, I had a school project. I built a CMS. I was traumatized by my SQL courses, and then I had like in France they teach you Maurice, which is a very strict method to do normalization. And with my whole team, we were like, "There's no way we're going to do this. We're going to do UML. It's easier." And it sort of drove us to use an object database. And at the time, that object database was called Berkeley XMLDB. And so I was using XML instead of JSON, storing objects in XML. So same schemaless kind of database, and querying things with XPath. That was an interesting experience. So there are some object database that use something else.
Yeah, so I would be traumatized. I love my SQL class in school. XPath is what would traumatize me. So yeah, JSON is a very popular format because it's a well-known web standard. There are serializers for every language and framework. It's pretty easy to read as a human as well, compared to something like XML. So, but there are some non-JSON, NoSQL databases out there, and a lot of these principles will still apply to those. It's just, do you have the stomach for dealing with XML, I guess?
Yeah. What is the best way for someone who isn't familiar with Couchbase to get familiar with Couchbase?
That's definitely your department there, Laurent. What do you think?
So if you go to cloud.couchbase.com, fish file, no credit cards required. If you go there, create an account, you will set up an instance for you, and there's something called the playground. And the playground is sort of a driven way, tutorial, a way to really take you by your hands and go through some very simple example until you get through some less simple example. And be more acquainted with all the power of Couchbase. You can execute some SQL query. You can also execute some code directly through the playground. So you stay into your web browser, into the Couchbase Cupola UI or manage offering for Couchbase. So I would definitely start by that.
Yep, Playground's a great way to get started for sure.
In your example, also Docker and Couchbase, that works if you wants to install Couchbase. That's that.
One quick comment on that is the question was CouchDB, and CouchDB is not Couchbase. So if you're doing something with CouchDB, you have nothing to do with Couchbase. It's completely different technology.
I guess we can do a little bit of trivia to link to the previous question as well about JSON. CouchDB 2007, I think, something like this, was a JSON database with a REST API. 2005, wow. Before MongoDB, before Node.js, was CouchDB, a JSON database with a REST API. And it merged with Membase, a distributed in-memory key-value store, which brought us the first version of Couchbase, a distributed in-memory key-value store with JSON support and the ability to queries MapReduce functions, which is a whole other discussion that we don't have to have today. But that was 14 years ago, and now it's two different products. Absolutely.
Yeah, not the same API, not a fork of one another, nothing like that. It's just kind of a historical, similar
history. All right. So in your example, you have not mentioned about document types. So is it be difficult to find the IDs and use it in the query? I'm not sure I completely understand that question. You have not mentioned about document types. We have a loose way of typing documents by using what we call collection, which is a similar concept that Mongo has. And so when you create a query, you have a context, you have a namespace. On a relational database, it's from whatever table. If you don't have table into a SQL database, then what do you use? We have a different granularity. We use buckets. Bucket is split into different scopes and into different collections. And a collection is the closest thing you have to a table. So that's what we would use to separate different types of objects of JSON documents. Of course, you can use a field called type or underscore type, or whatever you want to use in your JSON document that you can put into the workflows of your query, so that you can sort them out and differentiate them. If you have a user document with a country attribute, would you have a JSON document of countries for the application to query for selection, or would the app have a built-in list for countries to select from? That's a good question. It really depends on what you want to do and how often you expect the list of countries to change. I used to work for a CMS company, and the list of countries was not implemented as a document. It was implemented as what we call a vocabulary, a dictionary, a list of things that can be edited by an admin user. So that's how we did it at the time. But there's a variety of ways to do it. You can very well use a JSON document with a very specific static ID and just use that document to store the list of IDs. You can get an object from a JSON file or from a text file and load it when you start your application. That works too. I mean, there's a variety of ways to do it. Would I use an SDK to modify that list all the time? Maybe, maybe not. Again, it depends on which user you expect it to change that list. If it's someone in the app, then well, you sort of have to. If it's the maintainer of the app or the person that goes the app, then that's a different question. What's an ideal configuration for Couchbase cluster, number of nodes, etc. for production? It's another case of it depends.
I think the general rule is at least 3 for production in order to get the high availability benefits. But certainly that exercise of figuring out how many nodes and what each node should run is something that we've got lots of sizing material to help with that. But the only, the minimum guideline is like 3 nodes, 3 data nodes at least, so that you get the high availability. So if one node goes down, you'll have enough replicas to recover from that. But that being said, there are some side projects that I've run in the past, not major production projects that use a single node of Couchbase. My expectation is if that node crashes, well then, just like a relational database, I don't have any access to it anymore. But certainly for a real production, public-facing site, at least 3 nodes.
The other way to say this is that if your ability to make cache is impacted by the availability of Couchbase, at least 3 nodes. That's for sure.
Make cache as in CASH, right?
Yeah, not CACHE, indeed. What's the difference between Couch Database and CouchDB? I think we went over this. CouchDB is a different project than Couchbase. They have had different paths since 2010, so almost 15 years now. I don't know who's the vendors behind CouchDB. I know Cloudant was one of them, and they've been bought by IBM. So in my mind, CouchDB is an IBM project with a strong community in the Apache side of things, and I'm not sure what they've been doing for those 15 years, to be honest. We followed our own path.
Yeah, I would say the main difference is, CouchDB is a JSON database, but Couchbase is a lot more than just that. There are full text search, there's SQL, there's caching, there's mobile sync, there's analytics, there's time series. It's much more closer to a platform than CouchDB, which is kind of closer to a single point solution.
How do we sorry.
I was going to say maybe one more. We're kind of running low on time.
Yeah, how do we pacify the RDBMS brain cells to agree with that JSON is also a good alternative to store data? I don't think it's an RDBMS questions. I think the RDBMS has nothing to do with it.
So this is more like, I was using relational most of my career, although probably not anymore. But so it's kind of a bit of a shift, right, to go from relational to JSON. I think what helped me the most, and this is why I like Couchbase, is that Couchbase has the full SQL language. So that helps me shift my brain over to JSON a little easier.
Hey, team. So I think we're wrapping things up. I want to thank Matthew and Laurent so much for the great conversation and the overview of data modeling with Couchbase. We're going to have, again, a little bit deeper dive into this, part 2, coming up in February. If you check out the docs section, there'll be a link to that presentation. So, sign up and join us again. Please bring all of your questions. Also in the docs section, the presentation from today, if you want to review that. And I'll also add a link to the playground. You'll receive an email within the next day or so with access to the portal again, where you can view the on-demand and you'll have access to those docs again. So thank you so much for joining us. This was a really great session. Laurent and Matthew, thanks again. And hopefully we will see all of you in February for part 2. Have a great day, everybody.
Thank you, everyone.